Hello guys, this is Prime Concepts. Now in this video, I want to introduce a topic in maths. We want to consider coordinate geometry in maths, which will be starting with straight lines, right? Coordinate geometry. We'll be studying straight lines, be looking at some of the properties of straight lines. We'll be considering circles, looking at some of the properties of circles, the equation of a circle. We'll be considering the conic section, the ellipses, the hyperbola, and so on. So we'll be studying all of these things. Now, in this video, I want to introduce straight lines and study some things such as the distance or the length of the straight line. Now, we are considering this using the idea of coordinate geometry, and we are considering the Cartesian coordinate system. Now, to remind you, the Cartesian coordinate system is a system that considers a point in space using x and y axis. The system that locates points in space using your x and your what? Your y axis. That is what we refer to as Cartesian system. So if I put something like this P and I say x, comma y is a point, it means that this point is actually written or denoted in your Cartesian coordinates. So you would always see us mention x1, x2, x1, y1, x2, y2, and so on. So whenever you see those things are actually points in a Cartesian coordinate, which you can easily locate. Now, before we move to our study fully, I want to just remind us of what we have learned before now under your Cartesian system. How do you locate a point in space in your Cartesian system? Now, say you have a point P, which is, let's say, 2, 3, and you have another point Q, which is, let's say, 3, 1. So you have these 2 points, and you want to locate them in space. So we're going to do a rough sketch. So if I say this is 1, this is 2, this is 3, 4, and so on. This is 1, 2, 3, 4, and so on for my y-axis, right? So quickly, you should know that the first value you have is always your x, and the second is your what? Your y. So what is my x? My first point P is 2 on the x and 3 on the y. 2 on the x, 3 on the y. So if you trace this, you get the point. This is the point P, which is 2, 3. So we have located point P in space. So this is how you can locate a Cartesian coordinate point in space. Now I want to locate point Q. Q is 3 on the x and y on the y. 1 on the y. So this is point Q, which is 3, 1. So this is point Q, right? So I can decide to join point P to point Q. So if I do this, I have joined point P to point Q with what? A straight line. So we want to now look at some of the properties or some of the things about this straight line. And where we'll be starting from is, how do we find the distance between 2 points? That's the length of the straight line. How do we find it? That's where we want to start. So the distance of a straight line. Distance between 2 points. We want to look at how to find distance between the distance between 2 points, which is just a straight line. So we're going to take some arbitrary points in space. So we're going to consider, this is our Cartesian coordinates. So say we have point P, x1, y1, right? And then we have another point Q, say is given by x2, y2. So these are 2 points in space, and the line connecting them is a straight line. So we want to look at the length of this line. How do we find the length of this line? How do we find the distance between points P and point Q? So I'm going to call it D. Now, to arrive at the formula we use to find this, we're going to construct a triangle from this, knowing that there's a point somewhere here, which is actually our y1 and x1 somewhere around here. So I'm going to construct this so that if you know that this point is your y1, which is this is your y1, this particular height, right? and then this total height is your what? Y2. Then you can actually get, you can see this height is your Y1, which is this, and then the same way you can construct. Now, it means that this point is going to be Y2, which is the total height, minus Y1, which is the small height. So if you do same thing here, you know that this is your X2. Then this point also is your X1, so that this point in between is going to be X2 minus X1, right? Yeah, now, and you'll notice that this is a right-angled triangle, so simply means that we can use Pythagoras theorem to find the hypotenuse, which is the distance between those 2 points. So using that, we have that D should be this part, which is X2 minus X1 all squared plus what? Y2 minus Y1 all what? Squared. So this is how we can find distance between 2 points of a straight line, right? Now notice that what you have here is square. So it simply means that you can still write this formula like this and you would be correct. Instead of saying X2 minus X1, you can say X1 minus X2 all squared. Because of the square, you will still be correct. Plus what now? Y1 minus Y2 all squared. You will still be what? Correct because of the square. So you can use any of these formulas to find the distance between 2 points of a straight line. And let's take a quick example. To find the distance between P, which is say 2, 3, and Q, which is say 3, minus 1. So we want to find the distance between 2 points, P and Q, right? Yes, so we don't have to sketch. Even if you sketch, it won't be a problem, but considering your exam, you won't need to sketch. So you know that this is X1, this is Y1, this is X2, and Y2. You can still do the reverse. You can call this X2, Y2, X1, Y1. You will still be correct, right? Now, so solving for our distance, which sometimes is denoted like this. So instead of them saying D, they may just say find length PQ. Still the same thing. So it's going to be what now? Your X2, following this first formula, is going to be X2, which is what? 3 minus X1, which is what? 2 all squared plus what? Our Y2. Our Y2 is minus 1. Then minus, remember this is the minus here, minus Y1, which is what? 3. So I have this, right? Now if I solve, I would have 3 minus 2 is 1 all squared plus, now minus 1 minus 3 is minus 4. Notice I'm still using my bracket so that you don't bring out this minus unknowingly, right? And if you're punching your calculator, you do it this same way. So you have 1 square is 1 plus minus 4 square is plus 16. Plus 16, so that my answer becomes square root of what? 17. So this is my answer for the distance between the 2 points. Now, you want to know if this is correct. Use this formula again and try it. Then put your answer in the comment section.